Hello friends, this is my remaining video of lecture first where we have studied about the logic inverter designing of using NPN transistors. So here we have the simplified form of the circuit which we have already studied in the first lecture, where we are using two resistors at the input, but instead of two here we are using only single resistor, which not only reduce the cost but also reduce the size also and power dissipation too. So let's see what will happen when input is high and what will happen when the input is low at the output. And one question is why we are using or why we are studying about the single inverter. As we know already that ICs are available in logic inverter form 7404, which is TTL series. But why we are studying about the inverters? The reason is, suppose we purchase IC 7404 and instead of 4, if we have to use only single gate, so what about the 3 gates? These all go in waste. So to reduce this we are using only a single inverter. Okay guys, so let's see what happen when the input is equals to 5 volts. So apply Kirchhoff voltage law at the input side. We get 5 equals to IB into 1 plus zero point 0.7 voltage drop across VBE. 0.7 is because we know silicon equals to 0.7 voltage drop and germanium 0.3 voltage. So we get IB equals to 5 minus 0.7 equals to 4.3 milliampere. According to the relation beta IB, if we assume that the beta of this transistor is 100 multiplied with 4.3, we get 430 milliampere, which is too high. So this collector current, when multiplied with the collector resistance, a very high amount of voltage drop will occur across here. So our output will go negative, but instead of this transistor will give the output 0 volt or practically 0.2 volt. So we have seen that when the input is high, what we get the output 0 volt. Invert whatever be the voltage here, this circuit will invert it. Here we are giving 5 volt, it inverted, and we are getting the output 0 volt. Let's see what happen when the input is 0 volt. When V in equals to 0 volt, there is IB which will be 0 amp, because if input is 0 volt, there is no voltage drop across the base to emitter junction and transistor will be in cutoff mode. So according to this relation beta IB, IC is equal to 0 ampere. If there is no current flow through this path, so there is no voltage drop across the collector resistor. If there is no voltage drop, then the whatever be the voltage at here, it will automatically appear at the output, which will be 5 volts, but practically it will be 4.98 or 97 something. Okay guys, we have studied what happen when input is high and what happen when input is low. Here is a circuit which invert the input according to the requirement. Hope you like it.